In this session, we're going to discuss permutations and combinations. Let's start with permutations. The definition of permutation is a permutation of a set of distinct objects is an ordered arrangement of these objects. So first, you need to memorize about permutation. You should have distinct object. Okay, if say distinct object, we have a set, therefore it has an elements. So to create a pattern, okay, an element could only be used as one time. Okay, so we cannot repeat in using one element in a different position in our pattern. One time use of an element in a pattern. That's the meaning of distinct object. Okay. Second property that we need to remind um, property of the permutation, ordered arrangement. Okay. You say order arrangement, for example, we have two patterns that have the same elements. So for example, one is 1, 2, the other is 2, 1. So in permutation, they are different patterns. Okay, so it means we have two patterns, but they have the same elements. So in short, 1, 2 is different from 2, 1. Okay, they are not the same. Okay, so that's the meaning of ordered arrangement. So again, permutation of a set is a distinct object, is an ordered arrangement of this object. Don't forget these two criteria characteristic of a permutation: distinct object and ordered arrangement. Okay, let's continue about permutation. So an ordered arrangement of R elements of a set is called an R permutation. Okay, R permutation is basically, we're just going to get not all elements of the set that we're going to arrange. So for example, we have 5 elements in a set. We're just going to get 3. Okay, and that 3 elements will be arranged to create that pattern. And we call that 3 permutation. 3 means 3 elements from the given set. Okay, so another example. Let set S contains 1, 2, 3. Okay, 1, 2, 3 is one arrangement. So it's one pattern. Another example of a pattern, if we're going to reorganize 1, 2, 3 as 3, 1, 2, it's another pattern. Okay, so but in case we want to just to get two elements from set S, okay, so one example is 3, 2. Okay, 3, 2. And don't forget, 2 permutation means 2 elements that you get from the set S to create a pattern. Okay, that's 2 permutation. And for this, so if we're going to refer to R permutation, 2 permutation, so we could use this notation. Okay, so permutation of the population N in our container. Okay, so that's PNR. This is the population, and this is the number of elements in our pattern. And if we're going to connect it with our previous discussion, R is the container, okay, or the number of position on your pattern. Okay, so let's define all the 2 elements in our set S. Okay, 2 permutation. So we have 1, 2, 1, 3, 2, 1, 2, 3, 3, 1, 3, 2. As you can see here, 1, 2, 2, 1, they have the same elements but differ in arrangement. Okay, but they are counted separately. This is one pattern and another pattern. Okay, so going back, we have 6 patterns. 4 permutation of 3, 2. We have 6 patterns. And to help us to determine the number of permutation on a given set, we could apply theorem number 1. So if n is a positive integer and r is an integer with a less than or equal to r less than or equal to n, then the r p at nr is equal to n times n minus 1 times n minus 2 up to n minus r plus 1. Again, n means what? Sorry. N means the number of population, or is the number of elements that you're going to use for your grouping. Okay. So definitely all elements here, since you already use one element in the first, so on the second element, we subtract 1. Then on the third element, we subtract 2. And on the last element, we're going to subtract from n is r plus 1. Okay? And another way of writing this equation, so we could adopt the corollary 1. So this is another way of writing P and R. So the formula is n factorial divided by n minus r factorial, wherein n again is the number of population, r is the number of elements on the pattern, number of container. Okay, so that will be our formula. So using term 1 equation or corollary 1 equation will give you the same result. Okay, for example, we have 5 letters and we want to arrange it in a 5 boxes. Okay, so how we're going to organize it? How many ways? Okay, so on the first box, definitely, how many ways pwede anong laman nito? So we could have 5 possible ways. It could be A, B, C, D, or E. But on the next box, since we already put one letter on the first box, so we only have 4 letters, 4 possible ways for the second box. And for the third box, since we already allocated 2 letters for the 2 boxes for the first 2 boxes. So now we only have 3 left. Okay, for the third box. And for the fourth box, we only have 2 letters. And last, just 1 letter. Okay, so again, the number of ways for each box, okay, decreases by 1. Why? Because there should be non-repeating pattern, a non-repeating element. So that's why we are subtracting 1 from one box to another box. Okay, since there's no non-repeating element. Okay, so just multiply always for each boxes. So we have 120, or basically 5 factorial is equal to 120. So this is based on theorem number 1. Okay, multiply. But in case we only have 3 boxes, so what will be the result? Okay, so using theorem number 1 to determine the permutation. So for the first, we have 5 ways, 5 letters that can be allocated in the first box. On the second box, it's only 4, since we already allocated 1 letter on the first box. Okay, so that's why it's 4 here. And then on the third box, we only have 3 letters that can be allocated in the third box. So therefore, the permutation or the number of patterns that could be derived from this is 5 times 4 times 3 is equal to 60. Okay, so again, this is based on theorem number 1 formula. Okay. And in case you want to use corollary, so you could 5 factorial divided by 2 factorial will yield 60. Okay. So by the way, this solution just it just show us the relationship of 60 to 120. Okay. So the unused or the boxes, yung kulang na box is sure actually the divisor. Okay. The part that is not included on this given will be your divisor. That's okay, that's another solution. Okay. So again, this is based on corollary 1. Okay, let's have another example. How many ways are there to select a first prize winner, a second prize winner, and a third prize winner from 100 different people who have entered a contest? Okay, so again, non-repeating winner tayo dito. If you're already a winner in the first, you cannot be a winner on the second or even the third. Okay, so the solution will be permutation at 103. So first place, we have 100 possible ways times second prize 99 ways times 98 third prize ways. So multiplying this, we have 970,200. Or using corollary formula, so number of ways is 100, a number of population rather is 100. So 100 factorial divided by the population minus the number of elements that we are going to organize. So we have 3. So we subtract 3 from 100. So it means 100 factorial divided by 97 factorial. And it will yield the same result as theorem number 1. Okay. Another example. Suppose that a saleswoman has to visit 8 different cities. She must begin her trip in a specified city, but she can visit the other 7 cities in any order she wishes. How many possible orders can the saleswoman use when visiting these cities? So we have 8 cities and we're going to start on the first city, okay? This specified city, and then we're going to roam other city. So it's up to you how we're going to roam or how you're going to go to the other cities. Okay, so it means we only have 7 cities that need to be organized since the first city is constant. The other 7 is we're going to determine how we're going to traverse on those cities. Okay, so what will be our solution? So instead of 8 as your population, since the first is constant, so we only have 7. So therefore, using theorem number 1, n factorial, 7 factorial, result 5,040 paths. Again, we didn't include, we didn't include 8, we didn't use 8 because one city is constant. So therefore, we only have 7 cities that we need to organize in our going in traversing within these cities. So we have 5,040 paths that we could consider in traversing in going between these 7 cities. Okay. Another example. How many permutation of the letters A, B, C, D, E, F, G, H contains the string ABC? Okay, to answer this, okay, so we have how many letters? We have 9. But instead of considering, 8 letters rather. Instead of considering 8 letters, let's consider ABC as 1 letter. Okay, since this is the pattern, need. Okay, need to be constant na ABC siya lagi. So this will just be 1 element. Okay, so since ABC is 1 element, so D, E, F, G, H is 5 letters. So 5 plus 1, we have 6 elements for our permutation. So therefore, our solution will be 6 factorial is equal to 720. Again, why 6? Because we consider ABC as 1 element. Okay? We cannot change or alter the organization of ABC, the order of ABC. It will just be ABC. Will it be either on the first part or the last part or in the middle part? Okay? So that's why we are going to consider it as 1 element. Okay? 1 plus other letters. So 1 plus 5, we have 6. And then 6 factorial, 720 ways. Okay. Ways that the pattern contains ABC. Okay. So that's permutation. So now let's move on to combination. So the only difference between combination and permutation is combination is an ordered selection of R elements from the set. Okay. So in permutation, if we have the same elements but different organization, different way of writing it, they are considered different. But in combination, as long as a pattern contains the same elements, they are equal. So if we have AB and then BA, they are equal, they are the same. Again, if we have AD and DA, they are the same for combination. Okay, so for example, so C, combination of 4, 2. So we have 4 elements, for population, 4 elements in a set, but we're just going to get 2 elements for our pattern. Okay, so we have A, B, C, D. So we have A, B, A, C, A, D. BA is not considered as 1 element, as 1 combination because we already have AB. Okay, so kaya wala na tayong BA. So we have BC, BD. And for C, we have CD. CA is not part of the combination since we already have AC. CB, we already have BC, so that's why we didn't include CB. And D with A, we have already AD, so we don't need BA. DB, we already have BD, so therefore we don't need DB as part of our result. And DC definitely is not part of the answer since we already have CD. Therefore, these are elements. Okay, these are the combinations that we could get from ABCD with 2 elements. Okay, so that's combination. That's the difference. That's the distinction of combination against permutation. Okay, so for combination, the formula that we're going to use to determine the combination will be based on theorem number 2. The number of R combination of a set with n elements where n is greater than or equal to or greater than or equal to 0 equals combination nr is equal to n factorial divided by n minus r factorial. So, ngayon, sa formula, okay, ang difference ng permutation at combination is this r factorial. We include, okay, the other part, yung part, okay, that is yung ibabawas natin sa n will be part of the denominator. Okay? So let's have this example. So how many poker hands of 5 cards can be dealt from a standard deck of 52 cards? Also, how many ways are there to select 47 cards from a deck of 52 cards? Okay, so the solution will be, okay, so let's define first the population, which is 52, and the number of slots in our pattern, or in the number of container in a pattern, is 5. Okay, so based on that, so using the theorem number 2 formula, we have 52 factorial divided by the number of containers, which is 5, so 5 factorial, and the other cards. Okay, so the n minus r. So we have 47 factorial. Okay, by evaluating this is the result. 2,598,966 ways. Okay, for our deck of cards. Okay, so that's combination. So again, combination means unordered arrangement. Okay, against with the permutation. How about this? How many ways are there to select 5 players from a 10-member tennis team to make a trip to a match at another school? So we're going to get 5 members from the 10-member tennis team. And what is the combination of that 5 players? So using the formula, n factorial over r factorial times n minus r factorial. So the result is 252. So n factorial divided by 5 factorial times 5 factorial. Okay. Another example. A group of 30 people have been trained as astronauts to go on the first mission to Mars. How many are there to select a crew of 6 people to go in this mission? Okay, so only 6 people will be going to Mars from the 30 people that have been trained. Okay, so what will be the possible combination? Okay, from the 30, who will be the people? What will be the pattern? Okay, so using combination formula, so again, n factorial over r factorial times n minus r factorial. So it will be 30 factorial divided by 6 factorial times 24 factorial. The result is 593,775 ways in creating that 6-man team from the 30 persons that was trained for astronaut. That was trained to become an astronaut. Okay, so that's combination. Okay, so that will be my last slide for this video lecture. If you have some questions, kindly send me a message. Thank you for listening. See you on the next video lecture. Thank you.